lessons, we have went through the rules of differentiation. So in this lesson, we're going to be applying what we have learned. So we're going to be covering different forms of expressions, how they will be given. So let's say the first one we're given y is equal to 8x to the power of 8 plus 7x to the power of 3. So now what I can observe here is that we've got the power of 8, the power of 3, and I've got a constant multiplied to a function. In this case, my function is x to the power of 8, x to the power of 3. So now what do? I have to know which rule to apply and where. So first of all, I'm going to differentiate both sides with respect to x, all terms with respect to x, okay? So I'm going to take d over dx of y, equate that to d over dx of 8x to the power of 8 plus d over dx of 7x to the power of 3. So now, what do we know about a constant multiplied by a function? Well, what we know is that we're going to keep the constant and differentiate the function alone. So this will be 8 multiplied by d over dx of x to the power of 8. Plus, even here, I'm going to keep the 7 because it's a constant. Then I will differentiate the x to the power of 3. So now, d over dx of y will give you dy over dx. Meaning we are differentiating an expression y with respect to x. So now, likewise, I'm going to keep the 8. Now, I'm going to apply the power rule on this function x to the power of 8. So now, what am I going to do? First of all, I move the 8 to the front. This becomes 8, then x, and then I subtract 1 from 8, and I get 7. And then I enclose that. Plus, I keep the 7. I differentiate x to the power of 3. Well, I'm going to bring 3 this side, x, subtract 1 from 3, and then I have 2. I hope it's clear. Okay, so now what's 8 times 8? 8 times 8 is 64. So my answer is 64, x to the power of 7, plus 7 times 3 is 21. 21 x squared. And this is the differentiation with respect to x. So the key thing to note here is that a constant and a function, you keep the constant and differentiate the, the, the equation, okay, the function. Let's have a second example. Let's say now we are given y is equal to x plus 2, everything to the power of 3. So how will you differentiate something like this? Well, what comes to mind must be to expand the right side, okay? So now y will be equal to, I'm going to FOIL this thing. This means the brackets 3 times. So it's x plus 2 multiplied by x plus 2 multiplied by x plus 2. Well, you can multiply all of them at the same time, but if you can do that. But let's first multiply the two brackets over here, then we'll multiply the product to the other bracket. Now I'm gonna FOIL this. X times x will give me x squared. X times 2 will give me 2x. And 2 times x is also 2x. 2 times 2 is positive 4. And then I enclose that. Now everything is multiplied to x plus 2. Now, notice something here. I've got like terms. What do? I add like terms. So I'm going to have x squared plus 4x plus 4. And everything will be multiplied to x plus 2. Now I'm going to check the product again. I'm going to multiply everything in this bracket by every term in that other bracket. So first of all, I'll start with x squared times x, which will be x cubed. Nextly, I've got x squared times 2x times 2, which is 2x squared. Okay, so I multiplied the x squared to the term in this bracket, and I multiplied it to 2. Now I'm gonna do the same for for x. I'll multiply it to x and multiply it to 2. So now what is 4x multiplied by x? This will be 4x squared. And 4x multiplied by 2 will become 8x. Now 4 times x will become 4x. And 4 times 2 will become 8. So, hope you understand this. First of all, you take every term which is in this bracket, you multiply by all the terms which are in the other bracket. And at the end, we must have 6 terms, which is 1, 2, 3, 4, 5, 6. Now, let's add like terms. X cubed has got no like term, therefore we must leave it like that. 2x squared plus 4x squared are like terms, and they'll add up to give us 6x squared. 8 plus 4 is 12, and I'm going to have 12x. And then plus 8. So now my equation is in the form whereby I can differentiate it. So now what am I going to do? I'm going to apply the rules of differentiation separately. So for the first one, there's no constant. Okay, it's there, but it's 1. So I'm just going to apply the power rule. I first move the 3 to the front, then I add x to the power of 3 minus 1, which is 2. Okay, so let me write that nicely. It's 3x squared. Now on the second one, I'm going to keep the 6 and differentiate the x squared. Now the derivative of x squared, I'm going to take the 2 to the front, x subtract 1 from 2, and I'll left with 1. Plus 12. The derivative of a variable x will be 1. Okay, so we might not have covered that in any of the lessons, but just know that d over dx of a variable itself with a constant of 1 is 1. So d over dx of x will be equal to 1. Okay, so it's 12 times 1 plus. And again, the derivative of a constant is 0. So d over dx of a constant c is equal to 0. And now this becomes 0. Now let's find the final answer. This will be 3x squared plus 6 times 2 is 12. And the answer is 12x plus 12. Now this is how you can differentiate an expression with the highest power. You simply have to FOIL all the terms and then expand them, add the like terms, then while it's in a good state to differentiate it, you can differentiate. There are rules which you can use to differentiate something as short like this, but they're not covered in the content, and therefore I won't cover them. So now, let's say we've got another example. Suppose we are given y is equal to x cubed plus 4x, everything to the power of x. So what I will do, I will separate the expression and give the x to all the terms there. So I'm going to have y is equal to x cubed over x plus 4x over x. Now divide everything. We have x squared. X cubed divided by x is x squared plus 4. Now we can differentiate this. Now I'm going to apply the derivative, meaning dy over dx will be equal to what? I move the 2 to the front and I have 2x. It's 2x, then plus. The derivative of a constant is 0. And the answer will be 2x. Okay, so this is how you can differentiate an expression like this. First of all, assign the x to all the terms and then divide, then find the derivative. Remember that the derivative of any constant is 0, hence we have 0 over here. Okay, let's have a different one. Suppose it's given in the form y is equal to 4 over x. So now the question is, how do we differentiate this? Okay, remember from laws of exponents, 1 over a is equal to a to the power of negative 1. And therefore, if I've got 1 over x squared, I can take this x squared as my a and write this in the form x to the power of negative 2. This is equivalent to this, it's one thing. So now this means I can write 4 over x as 4x to the power of negative 1. Okay, why do I do this? Okay, so 4 over x can be written as 4 multiplied by 1 over x. And now look at this. 1 over a is a to the power of negative 1. And 1 over x will be x to the power of negative 1. And the answer will be 4x to the power of minus 1. Now, likewise, I've got a constant and a function. I'll keep the constant as 4. I don't tamper with it. And then I differentiate the function. I move the minus 1 to the front. This will be minus 1x. Subtract 1 from it. Now, I'm going to have minus 1, minus 1. And at the end, I will have 4 multiplied by negative 1, x to the power of negative 2. Now, what is 4 times negative 1? Will be negative 4, x to the power of negative 2. Remember, I can now return x to the power of negative 2 to its good form. Okay? So now this means that my answer is going to be negative 4 over x squared. And this is our final answer. Okay? So now when it's given in this form, first of all, you must write it in this form so that you can be able to differentiate it. Now let's go over another problem. Suppose I'm given y is equal to the square root of um of x. Okay, so how can I do something like this? Okay, when I'm given a square root, the first thing I have to do, I will say y is equal to x to the power of 1 over 2. I write it in a form whereby I'll be able to differentiate it. Remember that if I'm given a square root of a, I've got an invisible 2 over here, and I've got a power 1 over here. So I can write this as a to the power of this number divided by this number, this 1 over 2. Now what do? I apply the power rule. I've got 1 over 2 as my exponent this time. Well, I'm going to move the 1 over 2 to the front, and then x, subtract 1 from 1 over 2. Now I'm going to have 1 over 2 x. Now 1 over 2 minus 1, a half minus 1, we left with a negative half. This means I can take this part down because of the negative sign. This will be the same as 1 over 2 x to the power of 1 over 2. And what do you say about a to the power of 1 over 2? It's the same as square root x. So our final answer will be, you can leave it here, or you can go down and write this as 2 square root x. I hope it's clear. So this is how you can do this. So now what about if you're given something like y is equal to let's say is 2. Okay, let's put x to the power of 5. Now how will I do this one? Well, likewise, I'm gonna first write this thing in a form that I'll be able to